All right, so today we're going to talk about something called equivalent equations. Equivalent equations. So we're going to look at expressions and see if they're equivalent and understand what that means, explain why or why not. We're going to identify different ways that we can move or transform an equation into an equivalent one and state what it means for two equations to be equivalent. Okay, so our 6.1, two expressions, says that your teacher will assign you one of these expressions, expression A or expression B. Now, if we were doing this in class, which I will be doing in class, but for those of you guys who are not in class, maybe viewing this page, we're going to look at if we take and evaluate the expression when n is a certain number. We're going to take a look at what it would happen if we put n in for expression A. So if we put 5 in for n for expression A and then 5 in for n in these two places as an expression B, then we're going to put 7 in for n in expression A and 7 in for n in expression B. Let's see what we do. Do the same thing for 13 and for -1. All right, so let's start off with the first one. So we're going to take 5. Let's go with something more colorful here. So we got 5, and we're going to put it in for n in the equation. Actually, this is not an equation. Excuse me, it doesn't have an equal sign. It's an expression because it doesn't have an equal sign. So let's put it in the expression. So 3 times 5 plus 1 plus 6. Notice I'm just replacing the n with the 5. And then let's do the same thing with the second one. 3 times 7 plus 1 plus 6. And then we'll do it with 13. 3 times 13 plus 1 plus 6. And 3 times -1 plus 1 plus 6. So we're just putting, in each one of these spots, we're putting in that value for n and then working out what we are going to have. So now let's actually figure out what those come out to here. If we were doing expression A, we would have, to think about the order of operations, we could type this into a calculator, but let's do it in our head. We know either PEMDAS or GEMS order of operations. We do the grouping or parentheses first, then do the multiplication, then add 6 at the end. So let's do that. All right, so 5 plus 1 is 6. 3 times 6 is 18. 18 plus 6 would be 24. 7 plus 1 is 8. 3 times 8 is 24. 24 plus the 6 will be 30. 13 plus 1 is 14. 3 times 14 is 42. 42 plus 6 is 48. And last one, -1 plus 1 is 0. 3 times 0 is 0. And then 0 plus 6 is 6. All right, let's do the same thing for expression B. Now we're going to take each one of these n values, and now we're going to put them in for n in expression B. Now there's two places to put that number in for n, so just be careful with that. So the first one, we have 2 times 5 plus 1 plus 5 plus 1. And then we've got to put 7 in, so 2 times 7 plus 1 plus 7 plus 7. Actually, this is a 7, isn't it? So sorry about that. So up here in the first one, let's change that into a 7. And then we have a 7 here. And then in the next one, we have 2 times 13 plus 1 plus 13 plus 7. And then in the next one, we have 2 times -1 plus 1 plus -1 plus 7. So once again, in each one of the spots for n, right here, all the way through, we put in the number for that particular n value. Okay, so now let's actually figure out what those values are. Using the order of operations, or GEMS, or PEMDAS, let's go through and do parentheses, and then multiply, and then add. So in the first one, we got the parentheses, 5 plus 1 is 6. The other parentheses, 5 plus 7 is 12. All right, so 2 times 6 is 12, plus another 12 is 24. In the second one, we have 7 plus 1 is 8. 7 plus 7 is 14. So 2 times 8 is 16, plus another 14 would be 30. Third one, 13 plus 1 is 14. 13 plus 7 is 20. So 2 times 14 is 28, plus 20 would give us 48. And finally, -1 plus 1 is 0. -1 plus 7 is 6. So 2 times 0 is 0 plus 6 is going to be 6. All right, so what are you noticing here? You should be noticing that when we substitute 5 in for n, in both expressions we're getting 24. When we put 7 in for n, in both expressions we are getting 30. When we put 13 in for n in both expressions we are getting 48, and then -1 in for n, we get 6 in both of those expressions. So for a particular n value, we get the same answer in both expressions. This is what we call equivalent. Equivalent expressions or equivalent equations simplify to the same value. All right, so we know these are equivalent to each other, expression A and expression B, because when we substitute in a value for n, we get the same answer for both of them. So equivalent expressions simplify the same value, or they give the same answer when we substitute in a value for the variable. So even though they look different at first, they're actually producing the same result. So that means that they are equivalent.